So here we would continue with the experimental setup after the license plate is detected. So after the license plate is detected, we would do the license plate alignment and segmentation. After the detection and extraction of the license plate, a pre-processing algorithm is applied to autocorrect the sub-image to filter the noise, segment the character region, and to enhance the signal. Horizontal edge detection is performed on the extracted license plate to generate horizontal edge maps and to correct the alignment of the license plate. Hue transform is applied to the center portion of the license plate image to detect hue peaks to correct the rotation angle of the image. Morphological image processing. After horizontal and vertical edge detection is performed, along with the morphological image processing techniques like image dilation and image erosion, these techniques are applied to the license plate to find the dense edge area and edge peaks. This is done to crop the license plate image to a smaller image that contains character region of the license plate. Here we would see the original detected license plate which is extracted, and then the vertical edge detection is applied here, and the vertical edge after image close with the square structure and the profile close of as image close morphological operation is seen here, and the horizontal edge detection is performed here. Horizontal edge after image close with square structure, and the profile close of image close morphological image processing is seen here. So the vertical and horizontal edge detection along with the morphological image processing of image dilation and erosion results are seen here. And after the license plate is extracted, template matching and recognition is done on the characters. A database template consisting of 26 letters, 10 numbers, and some special characters such as a heart symbol are collected and used in this application. The font and the characters in the database are selected to match that of the license plate. After the character portion of the license plate image is extracted, template matching is done for license plate recognition. Segment image is first template matched with 0 to 9 numbers and several letters like A, E, and I templates to increase the success rates. The template is resized to match the input image with flexible scale of 60 to 110%. The signal level at each height ratio is recorded and applied for full plate matching. After the scaling ratio is determined, the plate image is ran for template matching for each character template. After all the characters of the license plate are template matched to the database values, the highest peaks are selected based on their locations. So here we can see the template matching peaks for the license plate, and this is the maximum profile of template. So this is the profile information. Here we will see the plate extraction, and the autocorrection is done here, and autocorrection and alignment, and after the autocorrection and alignment the plate is recognized here. So this is for plate 1 and this is for plate 2. This is the final result of the license plate recognition application, and we will discuss about the results here. The videos provide a convenient way to evaluate the algorithm as it automatically provides multiple images through various frames, and thus the images can be processed with a vehicle license plate recognition algorithm to read license plates and find the best fit, as images would differ in image resolution and quality throughout the video. It enhances the accuracy and reliability of the VLPR algorithm. The recognition correctly reads 104 frames and has 3 false reading from autocorrection error and 3 false reading due to recognition algorithm, whereas the extraction is 100% accurate. Conclusions. The VLPR algorithm is designed to read license plates from videos captured through personal devices which have low resolution and varying intensity. The application implementation is done offline with the help of the recorded video. All the steps of the VLPR processing, that is reading video, license plate detection and extraction, alignment and recognition, are implemented through various algorithms and validated through results. The software successfully reads video and displays the recognized license plate. The future research of VLPR can be concentrated on multiplates processing, high definition plate image processing, and ambiguous character recognition. So here we come to the end of the license plate recognition presentation. Now we will look into the code and how exactly the code works. So let's go get into that. So here we see the database which was developed for the license plate recognition. So we see characters from A to Z, the 26 characters, and some special characters such as a heart and an ampersand, and numbers from 0 to 9. This is the database, and the input video is seen here. The input video can be played, and it has the frames can be selected and the images can be seen from this video. Now let us discuss how exactly the code works in MATLAB environments. We will see that next. So here is the MATLAB interface, and we will see how exactly the VLPR algorithm works here, and how exactly the flow of the code is, and we would see that. So this is the database for the VLPR application, and here we would see the test input video, which we have seen earlier, and this is the main function. So this is the function where the input video is read here. So the video is read with the read video function. This is the input video, and the frame number is selected. So the frame number is selected in the input video. Image is read, and once the image is read, it is converted into a grayscale image. After the conversion is done to a grayscale image, we would get the binary image from the grayscale image. The binary image is obtained through the ARTSYS method. So here this is the code for conversion into a grayscale binary image, and we would go back to the main program now. Once we have the image from the video, from a particular frame, we would do the plate extraction. So the plate extraction is done here. This part art describes about the plate extraction. So the horizontal alignment and the vertical alignment is done here. So we would go into the plate extraction, where the Sabel filter is applied. So this function extract the sub image that include the license plate from the given image. So this is the sub image from the license plate of the given image. So first the vertical edge detection is applied through the Sobel filter, and after the vertical edge detection, image then Gaussian filter is applied to blur the image, and after the Gaussian filter is applied, a threshold value of 0.4 is selected with the color for additional filter. The color combine the color info. We combine the color info here, and various subplots are formed, but I commented them because there are a lot of plots here, and while running the program we get too many plots, and after the color extraction is done, the region shape with an aspect ratio of 1:2, this extraction is done. The region and the shape extraction is done. So this is the code for the region extraction. So once the region extraction is done, so the license plate extraction is done in this. We go back to the main, and after the plate extraction, image correction, that is the alignment and segmentation, is done. So we would go to reshape plate for image alignment and segmentation. So this function is given a license plate image, and to try to reshape the image to a rectangular front view picture. So first, to correct the angle skew through hue transform from horizontal edge detection. So the angle and the skew is corrected here, and once that is done, we detect the peaks in the hue transform. Once I commented the figure here because we get too many figures and it becomes difficult to keep a track of them. So but the program can be run by uncommenting them too. So once we find the orientation through the histogram from the peaks, so we get the average orientation through the histogram from the feeds, and we display the figures there. So once the image correction is done and the shape correction is done, segmentation is done. So in the segmentation, the horizontal and the vertical image edge detection is performed through the Sobel operator, And after the Sobel operator performs the horizontal and vertical edge detection, morphological image processing techniques are applied. So here we are cutting the top and bottom from the vertical edge, and after which we are cutting the left and the right by the horizontal edge. This is to extract the plate and cutting the whole plate. And now after we got the correct plate, we are segmenting the character part from the plate. So here the Sobel operator again is performed for horizontal edge detection to get the characters from the plate, and we are finding the peak around 1/3 of the height from the top of the top to find the upper index, and find peak around bottom to find the lower index. So we are finding the upper index and the lower index peak, and remove the first and the last dark. So this is the morphological image processing. We are removing the dark column if any. And once this is done, we go back, the segmentation on the character is done, and we go back to the main program. Once the segmentation is done, template matching and character recognition is done. So we will go into template matching and character recognition. So this function does that. This function is used for template matching to recognize the characters in the license plate. So so first we convert the input image plate into a binary image, and expect the characters to be at least half of the input image, and find the ratio corresponding to the largest intensity found, and from there we go to the plate decode selected to. This function is called by recog plate 2 to compute template matching peaks for character recognition. So the template matching peaks is done here. Read the plate information from the input image, which is a gray level image. So we fill in the default values and default template values, and then remove the mean from the input image of the plate. Then we load the template characters. So here we are loading the template characters, and once the template characters are loaded, it is through the database template matching. Convert the template images. The template from the we are converting the database images to binary images here, and get the binary template. After then we are getting the binary template here, and then there could be also the ones after we get the we debug plot of convolved image and horizontal profile. So this is the code for template matching, and we after various intensity peaks matching, and we find the vertical position of the peaks, and we find the horizontal peak position, and we get the final license plate recognized. So we go back to the main program, and this is how it is implemented. We would now run the program and see how exactly it works. So I have run the program, and we got the first image, the input image from the video, and I've selected the frame number of 75. So this input image is for the frame 75, and this warning is due to the graphical rendering feature, and that the size of the video is very large. So the warning is based on that. So this is the extracted image, and here we can see that for frame 75 plate 1 is recognized, and the result is 6MME075. So it is still processing, and we get the final output here. So this is the plate 1 and this is the plate 2. Plate 1 is extracted here, and then autocorrection and segmentation is performed, and it is recognized here. Plate 2 is extracted, autocorrection and segmentation, and it's recognized here. So once that is done, we will see we will see this yellow index line telling about the detected license plate. This is plate 1 and this is plate 2. So this is how the vehicle license plate recognition algorithm works, and this is the application of it. This project is implemented as part of pattern recognition subject with the University of Florida and EC department, and I would take this opportunity to thank Professor Dapang Wu for helping me through the course and with the project. Thank you.